What does that number mean? I'm sure that's a question many of you as maths teachers have heard and will continue to hear many times. So in this case, what number am I talking about? I want you to picture this scenario here. We have a teacher presents the following multiple choice question to her class. Another way of writing 6 squared is, we have 5 options, A, B, C, D or E. Now, students could have a number of different answers to this question depending on their prior knowledge and their understanding of the concept of index notation. The teacher in this situation has cleverly used a multiple choice question to determine the student's misconceptions. So as you can see to the right, we have 3 students' answers here. Student 1 believes it is E, student 2 believes it is A, and student 3 says, no guys, it's C. Each of these answers we know is obviously incorrect, but we can use this information to determine why they come up with these answers and what misconceptions they have around index notation to make them think their answer was correct. And from there, we will help them overcome this error, and they'll be A+ students in index notation. Alrighty. So as you know, this video is based around the concept of obviously index notation, with particular focus on the student misconceptions and what we can do as teachers to help them overcome this problem. So we know that index can be defined as the number of times the base is repeated in a product, and is written as the small number to the top right of the base number. The term index can also be referred to as power and exponent. So upon teaching this topic, it's important that we teach our students the 3 different terms as they are referred to as these terms in higher grade levels in mathematics. A simple way to introduce index notation to our students is obviously to build on what they already know. In grade 6, they were introduced to the term squared number, which they should know as a number we get after multiplying the integer by itself. This presents a good starting point for teachers to introduce the index notation to, which as we know is squared, and then from there we can eventually introduce cubed. The concept of indices is first formally introduced in Year 7 under number and place value, and its content descriptor states that students will need to investigate index notation and represent whole numbers as products of powers of prime numbers. As we can see on the screen here, the concept of index notation is embedded in almost all areas of maths, making it extremely important for students to understand early on. As you can see in the PowerPoint, each of these units use some sort of index notation right up until grade 12. There are a number of misconceptions associated with index notation. That's why it's so important for teachers to ensure their learner understands the concept before they continue their high-level math subjects. So, as you can see, we're referring back to that first question we looked at the start, looking at the 3 answers that the 3 students gave us. The first student said the answer to the multiple choice question was A, 6 squared is equal to 6 plus 6. This incorrect answer is simply a result of the student not being familiar with this shorthand notation with our index number. They may assume that the small 2 means 2 lots of 6, therefore 6 plus 6. Teachers can correct this misconception by using simple representations of the area of a square, as you can see here in this diagram. Students are already familiar with the formula for finding the area of a square, which they know as S multiplied by S. We as teachers can extend on this and by showing how this rule can be represented as S squared and still mean the same thing. This can be done through drawing diagrams and in-depth explanation. We can explain to the student that a value multiplied by that value by itself can be represented as the S squared. The second student, as we can see here, answered multiple choice answer C, saying 6 squared is equal to 2 multiplied by itself 6 times. This misconception may not be as common as the others, but still can occur. In this case, the student has understood that the small 2, our index, on the top right means a number multiplied by itself. However, in this case, the student has mixed around the base and index, mixed around these 2 numbers. Rather than multiplying the base of a number of times equal to the index, the student has multiplied the index a number of times according to the base. So, what is it that we as teachers can do to avoid and address this misconception? This error may be simpler than the others to overcome, as a student maybe is on the right track but has just executed the answer incorrectly. So we as teachers, to help them overcome this, should give the student an example. And we have here where we have base 5 and our index as 2. Ask them to label this according to the base and index and give a definition for each. You can see there. That way they understand exactly what both mean. After that, students should do some practice questions and refer to this diagram till they understand and get the answers correctly, consistently. This brings us to student 3's answer, which was multiple choice answer E, saying that 6 squared is equal to 6 multiplied by 2. This is the most common error students make, as they forget the meaning of shorthand notation and interpret the index as meaning multiply the base by the index rather than multiplying the base by itself, the number equal to the index. In simpler terms, the student is multiplying the base and the exponent or index. As this is the most common misconception for students, we as teachers need to address it in a way that will make them understand on a deeper level. You cannot just simply say, that's the rule, so that's why it works. We must show them physically. Once students understand that the power of 2 can be referred to as the number squared, we can use this physical diagram to show how this actually works. So I'm now going to do a simple demonstration of how we can show our kids using physical diagrams the concept of index notation. Alrighty, so we have 2 6's. Once we have explained to our students that a base number to the power of 2 can be referred to as something squared, we can get out these physical diagrams and explain how a number multiply itself creates a square, making it a square number, something they're already familiar with. We can also show how the answer they gave us doesn't work. C answered that it was multiple choice answer E, saying that 6 squared was equal to 6 multiplied by 2. Once I understand that a number to the power of 2 is a number being squared, we can show that 6, we got here, 6 divided into 6 multiplied by 2, thus 12, which doesn't give us a perfect square. We can then go on to say that because something to the power of 2 is that base number, 6, multiplied by itself, we can show 6 multiplied by 6 like we have there, we can show that gives us a perfect square. So when this concept comes up again with our students, they can remember that that index notation to the power of 2, then the number it equals must represent a square. Therefore, both sides must be equal to each other. Therefore, it must be that number times by itself. We need to give them something to build on so they can make connections to understand the new concept they're learning. Thank you for listening, and hopefully it's a useful tool for you. Thank you.